So here we have a visualization of alternating fueling station dataset in the United States. So the abstract of this dataset, we visualize the fueling stations across the map of the United States and infer some details about it. So I will be discussing the first task, visualize distribution of alternative fueling stations across the country. So in the first task, we have a bar chart comparison of fuel states across the states of USA. In this visualization, we can clearly see that California, in the number of fuel stations, California dominates every other states in the United States. Then we have a fuel stage distribution across the country on basis of ownership. In this pie chart, we can clearly see the ratio of local and municipal government-owned fueling stations is in the majority. And then we have a heat map of fuel stations across the country. From the heat map, we can clearly see the dominance of California in the number of fueling stations, showing potentially reflecting its vast population, economy, and perhaps progressive energy policies. Then we have a heat map distribution comparison of fuel stations across the year. The heat map analysis reveals the general decline in the fueling stations as can be seen from 2012 to 2015, and from 2015 to 21 there is a vast decline, but some cities like California retain their number of fueling stations, showing their progression in different fueling styles.
I will be explaining task 2, in which we have done analyzing trends in distribution of various fuel types offered by fueling stations throughout the country. First visualization is of distribution of fueling stations by fuel types over time. We can clearly see that from 2012 to 2021, the number of electric fuel stations are increased over time. Second is a pie chart showing distribution of fueling stations across different states. We can clearly see that electric fueling stations dominate in every state. Exceptionally, 85 is dominating states like South Dakota and Minnesota. Next is count of fueling stations by fuel type. We can clearly see that electric fueling stations are increased over a time. Next, we have state-wise fueling stations density for various fuel types, in which we can see that California is dominating in all fuel types. Next, we have relation between the fueling station and laws and incentives given by the state. Here we can clearly see that there is a positive relationship between states offering greater incentives and possessing more comprehensive green energy related legislation. Next, we have fuel consumption trends for different fuel types, in which we can clearly see that CNG is dominating over the period. But in 2019, we can see that there is a decline in CNG, which is basically due to the rise of electric vehicles.
Here I will be discussing task 3. Here we will be exploring distribution of electric vehicles and analyze pricing trends, growth trajectory of electric vehicles over time. So this is the task 3 for that. First, electric vehicle distribution. We can see from the graph from the maps that there is a clear correlation between the density of registered EVs and the concentration of EV charging stations. Areas with more extensive EV networks witness a higher number of EV registrations, underlying the importance of infrastructure in driving EV adoption. For efficiency ratios, first let's look at car classification bubbles. Here from this chart, we can see that small electric SUVs and electric mid-sized cars emerge as dominant categories in urban areas, capturing the largest market share and reflecting urban consumers' preferences and practical needs. And this is the efficiency ratio comparison for them. Now the sales for hybrid electric vehicles and plug-in electric vehicles, we can see from these charts that there has been a sales surge in 2018. Both hybrid electric vehicles and plug-in electric vehicles witnessed a significant sales surge in the year 2018, indicating a rising consumer interest or potentially beneficial policy changes during this period. Now here is the chart for EV charging rate distribution. Here we can see from this chart that charging prices for EVs are notably higher in major urban areas such as California, Florida, and Washington. This could be attributed to higher demand, operational costs, or premium services offered in these cities.